Okay. Good morning, everyone, and welcome to the Performance and Debugging for Web Developers session. So I'm Konrad. I work for RIM. I put the Web Inspector, which is the tool that we're going to be talking about for you guys. I was one of the people that helped put it onto the original playbook way back when it launched. We have the tool available also on the BlackBerry 7, and we're going to be showing it to you on the BlackBerry 10 device today.
And for those that don't know me, I'm Stanley with the Developer Relations team. I actually know almost everyone in the room today, which is great, so thanks for coming. Konrad and I are actually really excited when we sat down to actually build this deck. We're both very passionate about this specific subject, so it's a real treat to actually be able to talk about it today.
Yeah. So we're going to be jumping back and forth between the slides and the demo. It's going to be very much an interactive demo that we're going to be showing you guys. And so we're going to start off with the timeline view, and then everything will flow from there.
Yeah, so the experience today is we're doing a brain dump of information about debugging in the browser. We want you to be completely enabled and armed after this event to go back to your own code and your own applications and reduce the amount of time it takes to troubleshoot and optimize. Right? Because spending hours working on a specific bug is a big waste of time, honestly, and it costs money, and it costs gray hairs, and I have a lot of them, as you can tell. So we hope we're going to impart some knowledge on everyone today that's going to allow you to be a bit more successful in that regard.
Okay, so we're going to start off with the Brick Breaker Bold demo. So if we can have the HDMI. Okay.
So has everyone had a chance to see Brick Breaker yet? No? All right. So Jen Mack from the browser dev team created this project on her own, just as a way of saying, hey, everyone, BlackBerry developer or users know Brick Breaker. It's sort of ingrained in the actual smartphone. Let's see if we can do this in HTML5. So they rebuilt it completely from the ground up, and we actually just open sourced it. So you can go to github.com/BlackBerry and download this application and play around with it as you like.
The link is on the next slide.
Sweet.
So I'm just going to show you a quick run through. So there's 3 different modes. Obviously, we're going to go for the easy one first. And this is touch screen, so you can see I'm moving the guy. Oh. Do we have audio from the...
You undo the...
No, there's
unmute the
sound
game
effects
audio
when you hit the bricks. But there you go.
So we got HTML5 audio going. We got animation frame. This is a canvas that everything's being rendered on.
Yeah.
Touch events, as we see going in there.
Disabled the sound effects, but enabled audio. So, one game mode. Oh. Turn to main menu. Intermediate is the same with just paddles to touch, but this one here is with orientation. So I'm tilting the device.
Yeah, so the hardcore mode, is it accelerometer?
Yeah,
the device
it's
motion.
device motion, or no, device orientation, I think.
Cool.
We'll get into all the details of how that goes, but yeah, so that's Brick Breaker in a nutshell. Can we go to 1? So, surprise, this version, I know you guys saw that it was a little choppy and sloppy, but that's because we've introduced some bugs.
Yeah, I've
for us to take a look at.
Purposely built some errors into it, and the purpose of that is we're going to explore Web Inspector today to find them and to troubleshoot that and fix them. All right, so we noticed some performance bottlenecks. The ball wasn't as smooth as we'd like to have seen it. There's actually some layout issues in certain parts. We're going to see how you can use Web Inspector to find those rapidly and get to the bottom of that. And then, of course, the link to where you can find this code yourself. And
this is the one, the non-buggy version link.
Yeah, of course.
Okay. So let's go ahead and if you saw on the when we opened the app, there was a pop-up which displayed the link, which displays the URL. And can I have 2? So here, if we go to the link that it shows, This is the Web Inspector landing page. This is the page that will be shown once you connect to the device. So right now I'm connected to the live device. And so there's a couple different web views. Again, there's bootstrapping. There's an overlay for natively skinned controls. But what we're interested in is this one right here. So starting with the timeline, what we're going to do is just record a bit. Sorry, I'm just going to run, record. Something's going. OK, so we have lots and lots of events in our timeline, as you can see. So things that are interesting, just the usefulness of the timeline. So at the bottom here, there's some controls to basically modify how the web view is displayed. So you can toggle which events are visible. So got rid of all scripting events, bring them back. So you can see in the top when they go gray, so we can get rid of rendering. And then there's painting. Small UI bug in Chrome, unfortunately. It's not making this easy. And loading events, if we were to load resources. So this helps you filter out the different events and makes it easier to see which ones are the troublemakers, which ones are not. This filter over here, well, as it says, hides records shorter than 15 milliseconds, so it'll remove a lot of the unnecessary ones. The ones you care about are the ones that are usually longer than 15 milliseconds, because that's the average length for getting 60 frames per second. It's the average length of time. And again, this last one here basically glues synchronous to asynchronous. So you can see when the timer fired that it was responsible for a lot of different things. So we want to put it back so that every single event, when it's called, it goes back to its root cause. So you know the timer fired, well, it was a draw event, and it keeps firing over and over and over again. It knows it's from the same place, so it basically syncs all those things together.
So does anyone use XHR or AJAX a lot in their applications? Yeah.
Yeah, or set timeout or request animation frame. That's what these will sort of sync up for you guys.
Yeah, so if you wanted to actually see the impact of the performance for that piece of code or that script in your page, the events view of the timeline will give you a quick snapshot, just like a visual representation of how long it takes to get your callbacks to flow through that full XHR event in a visual way.
No. So as you can see from the different events, if you hover over them, it will give you more information. I'm not sure why. There we go, the hover. So this shows you the call stack, so which line in the code initiated this specific request. There are other events. So let's take a look here.
Did you see what you just did there? You actually changed the timeline, the start and the end snapshot, so almost like a magnifying glass.
Yeah, you can scroll through, so you can only see the events that you want.
Do you want to isolate a problem? You can scroll down to say what you want now. The 8th second of your simulation, you're now focused on just the events that happened during that time frame.
Yeah, so if we have this specific event as the on-touch start, you can expand the events so you can find out, okay, the touch start event, it initiated a function call which came from jQuery. So now the interesting thing here we have is that even the recalculate style and the layout will tell you why it happened. So this layout was from audio.js line 88, which was from jQuery min line 3, another jQuery min line 3, and then called in from native somewhere. Again, for the recalculated style and the layout, just a different call stack. The other fun part is we have paint events, right? When you hover over these, different sections of, can I get number 3? So I'm hovering over the different painting events. It's a 145 by 145 section. That's just how we do the paint calls. And they're being they're painting in different regions, different areas, so it shows you where it's painting, not just that it occurred. So can I get back on 2? So it shows you the dimensions and the location. So it actually draws that for you on the screens in a nice little hover.
So if you see a really long paint event, Konrad, what would that typically mean compared to, like if this example here, we got 2 longer green bars compared to very short
Yeah, so it
blips.
took 25 milliseconds for that, and this one took almost no time at all.
Mm-hmm.
The longer paint call, maybe there's more. Well, let's take a look, see what the different regions were. It could be for various different reasons. Maybe you had to composite different things, or there's more information to display there, or to pull in. I'm not sure specifically. Painting's not my area of expertise, unfortunately. But Web Inspector is, so.
All right.
Right, so yeah, like you said. Yeah, so just we're going to repeat. So yeah, if you have transparency and overlays, so there could be something that would be important there. Let's see what we have next. Oh, yes. So as I said, we have the call stacks. Now, the fun part is these are actually links. So if you go to click on Audio.js line 92, it will take you in your resources to that specific line. So we have right here. So you can walk that call stack, and it'll take you to the resource panel.
And that's something that we really wanted to demonstrate, was how integrated each of the pieces of Web Inspector are with each other. I mean, you can start in the timeline, and before you know it, you float into the resources or the console or the other features of it quite seamlessly, because they all work really well together to give you information.
Yeah. So now we're at resources, let's actually take a look at what this beautiful little tool can provide us. So they're broken down. The resources is broken down by frames. So if you had multiple frames, they would be listed separately. So we have just our index.html. And we can take a look at the raw source. So this is the source that was transmitted over the network. That's what the browser interpreted. So we can see every little piece of that. We have, again, the style sheets, every single script. There's quite a few, as well as all the images that we have. So you can take a look at the images, get all the details about them, so we can see, the full dimensions, file size, where it was pulled from, the MIME type transferred, and so on.
There's one thing that I do want to repeat what Konrad just said. Initially transferred over the network. So you can go back to the HTML file and just look at its contents. What you're seeing is what the application first loaded before any JavaScript did anything, before it changed the DOM or added content to the page. This is what this file looked like at the start. So if during your investigation you're troubleshooting something, you're expecting your JavaScript module to add something to the page or do something, this is a great starting point to see if, okay, let's make sure that everything was interpreted initially as we expected it to before we explore the other panels, which we're going to get to in a moment.
Yeah. So here you can take a look at all of your databases, any local storage, session storage, cookies. So there's no specific cookies here, but it's all visible, as well as application cache, IndexedDB, and so on. So now that we have the raw HTML is over the network, let's take a look and see how this guy changed in the actual elements panel. Now, similar to how the painting calls did an overlay of the screen, when you hover over the different elements, and can I get 3 again? We have visible on screen the full container, what this div takes up, where it's located, its identifier, so it can be the ID or the name, and it'll display it in the CSS selector that would identify this, as well as its dimensions. So if we drill down, we can see we have the moon, we have, let's see, oh yeah,
So Konrad's
the whole-
hovering over
the whole background image area. We have
elements in Web Inspector right now, different ones within that main container.
yeah, the HTML5 logo, BlackBerry logo. So I'm going to come back. Can we get to number 2 again? So we're going to come back to the elements in a little more detail in a bit. But we have a way to debug JavaScript, which is really some of the fun parts. And so now that I've enabled sources, clicking on the timeline here will take me to the actual sources screen, because we've enabled script debugging. So instead of taking you to the resources like it did before, now that we have it enabled to view, to debug, will be transported from the timeline to the sources instead. So it really does flow. And the reason sources are disabled is that it does have a performance impact to enable script debugging versus not. So if you don't need to do that in your investigation through Web Inspector, we don't take up that time for you.
So what you're saying is when source scripting is enabled, the values in the timeline view may be
They may be altered.
misrepresented?
They may be altered slightly. There is a performance impact when you have Inspector connected at all, but it is still representative of the issues you would be experiencing. They're not going to be caused by Web Inspector. It's just going to be easier to investigate. So. And as you saw, so we had some performance issues in the.
I'm sorry.
Oh, so on the bottom here, there's this checkbox here. So you have debugging enabled, and if I deselect that, then it takes you to this screen here where you need to enable the debugger by just clicking it. And this will always happen when you connect Web Inspector. It'll always be disabled, so you have to click to enable. So in the timeline for draw, we would click, oops. It should take you to the resources. It will initially when you first load it. Just discovered some work I have to do when I get back.
Right on.
But when you go to the timeline initially on first load, if you have script sources disabled, it'll take you to the resource. And so because we have it enabled, it'll take us to the sources now. And it's either or, but it's only if you have, yeah. OK.
Let's talk about breakpoints.
Yes, breakpoints. Awesome spot to start. So if you see down at the bottom, this is a great catch-all. Right now, it's set to pause on every single exception that we have. So you can toggle through. So we have pause on all, pause on uncaught exceptions, and this is don't pause on exceptions at all. So the debugger won't just do anything. Exceptions will just be thrown to the console, and not caught and not stopped. So that's the very basic way to set breakpoints. The other one is to add a manual breakpoint, which we've just hit because the animation loop gets called all the time. This call stack is very short, so let's set a breakpoint somewhere else inside the actual frame and continue. So we're inside, it's saying it's an anonymous function, window.requestAnimFrame. This is a function we have. And walking the call stack, you'll see that the location of where we're broken does change. The local variables we have access to also change on us. So if we were to take a look at this little tool. So here we have just a way to execute in the console. So we'll take a look at arguments. And so an empty array. Let's go back to a different function. Here we have callback. And so callback is visible at this At this scope, callback is visible and we know that it exists. But if we go back to the other point in the stack, if we execute callback, it's undefined. So the great part is that we're able to change the scope of when we change the spot in the call stack, it changes the scope. So it maintains the closure that you have available in that point in time in your code. So any local variables you have declared inside the method or in that closure will be accessible to you when you're doing your debugging. And yeah. So that's basic breakpoints. And that's just, actually, before we continue, can I just go to number 3 really quickly? So you can see at the very top, I'm not sure if it's easy to make out, but what that says, it's a nice little overlay, and it says paused in debugger. So it lets you know, when you're moving around, I'm touching the screen right now, there's nothing going on. Before, you'd be saying, OK, why is this not working? There's issues here. What's going on? Now there's a nice little clear message saying it's paused in the debugger. Don't worry, nothing is broken here on your end. You're debugging something somewhere. Get back to 2. So let's just uncheck that breakpoint and continue. We have DOM breakpoints and XHR breakpoints. So if you try to add a breakpoint on XHR, any XHR, it'll pause in the debugger for you right now.
That's super cool.
Yeah.
I think that blew my mind the first time I saw that. Not only does it listen for XHR breakpoints, but do you mind throwing in a custom one, putting in showing actually how you break on XHR? It's not like you don't select a line, you enter a URL. So it's like any time that this application tries to access a resource over XHR to google.com or developer.blackberry.com, Web Inspector is going to catch it and break on that. So it's really versatile and flexible that way. Oh yeah, here we go. So we're in the console right now, and Konrad's actually...
I'm trying to remember how to do this. I usually just take boilerplate code. Want help? I'm trying to remember.
Yeah, I'm not a syntax guy. It's cut and paste, man.
I know. It's copy pasta. Anyone help me?
Here we go. Crowdsourced coding. Let's do it. I know that send is the last statement, but what does it get? No. It's...
So anyway, this is a nice little autocomplete feature we have, so we can see what the actual things are.
Open.
Open, yes.
That's it.
But I just wish I knew what the parameters were.
It's get. You start with as a string, followed by a comma, then a URL.
We can put an empty one because it'll break regardless.
Yeah, and then I think false for synchronous. There you go.
Oh.
And x.send will do it. Boom.
Boom, paused in the debugger. And so, I know it took a little bit longer than I wanted, but we can see this is within this command line, this block, these are the actual local variables we have access to. So this was all done in the console, so really the program is just x.send. But if wherever you would have this in your code, it would pop up in the debugger for you.
What's the current scope? Is this the
This
global?
is just the scope of. I'm trying to determine what the scope would be, but it's when it.
It's probably the global, huh? You have probably access to window at this point.
It's within the block. We would have access to window, I think. Yeah.
Okay.
But it's at the block level when this is actually being sent. So instead of just when you setting a breakpoint in your on response or on error function handling, you can do it when the actual XHR is being sent or has been sent. I'm trying to remember which point it was, but event listener breakpoints. So we have a nice touch device, and we can set touch event listeners. Right now, I tapped on the screen. We have the event handler that fired this. Really nice way to debug any touch events. So you can put in mouse events, keyboard events. So key up, key down, so on.
This would be super awesome for anyone using libraries that don't necessarily handle touch events gracefully or nicely. I know in some cases, There's some libraries that focus on gestures rather than actual tap and touch events. So if you're having problems in your apps and it's not responding correctly, set some touch breakpoints and just dig into the code and see what it's trying to do. And at least you know what's happening, and then you can make a decision how to fix it after that.
Yeah. So walking through, you can see what's being executed and so on. So.
And did you already show it? Say you have like 20 breakpoints in place. Can you easily toggle all of them on and off? Have you shown how to do that?
Oh yeah, if we can just go set breakpoints.
Yeah.
We've already toggled the original one we had, but we can just basically toggle these so that they're disabled, so it won't break at that point. And so you can have set as many breakpoints as you want, disable them all, enable the ones that you need at that point, and so you don't have to delete the breakpoint. You can just click in here. And touching or clicking outside of the checkbox takes you to the location in the code where it was set, which is super useful to have. So you can just lightning quick jump back and forth between the different portions that you have of your code.
Do you lose the breakpoints if you end your debug session? Disconnect?
Yeah, so let me just repeat that. Do you lose your debug spots? No, you don't lose them. Web Inspector, as you can see, is an actual HTML. We're going to a website, so this is web content that's being displayed, and it uses, I'm not sure if it's cookies or local storage. I think it's local storage to maintain all of your preferences. So it will maintain all the breakpoints you have, all the open files you have. You notice that when we started going into the sources panel, there were already a couple of the JavaScript files were open, because here you can navigate between them in a tabbed view. But you should be opening them through the sidebar here, which pops up. So it maintains a list of open files, your breakpoints, and even the last panel that you visited. So right now we're on sources. We can switch to network or resources. But when you close Web Inspector and open it back up again with the same URL, we'll make sure it's the same IP address of your device every time, then it will maintain that for your page.
Konrad, I don't believe you.
Oh, no, you don't think so?
Put your money where your mouth is.
OK, so let's copy this URL, open up a new tab, enable the debugger. All my breakpoints are back. Open files are there, so everything's good to go.
Sweet.
Yes, you can applaud. Go ahead. I encourage that. Yeah.
All right, I believe you.
Don't doubt me, Adam. OK, DOM breakpoints. So this is a nice little part. We have, oops, just paused on my touch event. Let's get rid of that guy, because we don't want him just yet. We'll go back to the Elements panel. See, so we have the container here. And the way you set DOM breakpoints is you right-click. Now, this is a context menu that is brought up by Web Inspector. This is not the normal context menu that you would have. This is something they override. But we can set breakpoints on the subtree modification, attribute modification, and node removal. And you can set this on any breakpoint that is not a head or a script. So no meta tags, no script tags, no style tags. But all other tags are good to go, and you can set all the breakpoints you want on them.
So a real-world scenario, imagine you're troubleshooting a page that an element disappears for some reason, and you have no idea why. And 2 hours into digging through hundreds of lines of JavaScript code, you realize, oh, I could just set a DOM breakpoint on when this thing is removed, and it'll tell me exactly where it's happening and when it's happening. That's the intent of this capability. Anything.
Anything. Yeah.
Except for, was it the head element?
Yeah, the
in
head.
HTML?
Head element.
Yeah. Is it body, maybe?
Body you can set. Let's. Oh, those are in the notes.
Oh, you're right. Mostly page content, so stuff within the body tags. Any sort of divs or Ps or any markup that's found in there.
OK, yeah. So I just went through the main menu to navigate to the going into the beginner mode of the game. You mean this?
Boom.
Yes, it does. We have pretty printing of JavaScript, and that's something that everyone wants and needs when you're using jQuery, especially jQuery min.
Everyone saw where that was? That little
So yeah, this
braces at the
is
bottom?
the curly braces at the bottom is where that happens.
And you can unprettify it if you want.
And yes, you can
Just
make
see
it
the
ugly
original.
again if you'd like, but we're not going to do that to you, not today. So this is the DOM breakpoint, and so we can walk through the entire tree as to where all these breakpoints are being set, where everything comes from, and again, you have access to A, B, C, D, E, F, G, all your nice local variables at the scope. So you can see where it's in our code, where it goes through jQuery, all the different files that are accessed, and they all stay open at the top here. Small little quick thing, these little guys, he doesn't want to go away, but you can bring up sources, you can have it stick, or you can make it disappear. The right side should be working. I'm not sure what's going on with that right now, but we'll move on. Yeah, so let's continue on. Oh, still more DOM breakpoint being hit. So let's disable the DOM breakpoint. And just to make sure, it is still visible right here. And so when you click on it, it'll take you back to the container on which it was set. So it'll identify that node for you, or the location of that node if it was removed. So what we're going to do is we're going to take a look at the moon back here. Or was there another element that we wanted to take a look at, which would make more sense?
No, let's start with that one. So
Okay.
back to the elements panel. I'm just going to focus on some of the features of this. So if you
Yep.
can select the moon, which is on the home screen.
Yeah, we have the moon. So
There's neat things that you can do in the elements panel. So you can actually modify markup in real time. So if you wanted to tweak how certain things are displayed, rather than updating your actual HTML file, rebuilding the app, redeploying it, you can do all your changes through Web Inspector, and it'll update live on the fly. Is there any specific examples of that we can do in here?
of course there are.
Cool.
So right now you can see here there's the CSS matched CSS styles that we have. We can see the default styles that come from WebKit, or the inherited, and also any inherited styles it would get as well. It's a pretty long list, so it's usually disabled by default. We're interested in modifying the style here we have for the moon, is what its position is, and so on. So if I update this, you can go in blocks of 1, or you can see how it's being modified on the actual metrics. We're going to get to that in a minute. And if you can go to number 3 for a minute. So the moon is just changing its place. You can move it up and down. That was in increments of 1. We can go in increments of 10.
So it's a lot more than just a
Back to the
debugging
original.
tool.
We can change its width. Oh, it's a big moon. Oh, I like that size.
That looks better.
We should tell Jen to keep this.
Yeah.
Or we can submit the change to GitHub ourselves because it's open source.
Wouldn't she love that?
Yeah, she'd love that. Yeah, so we like the moon. Actually, I want to make it a little bit more visible. No. Let's go back here. And let's make it a little bit higher up in the corner. Yeah. It's a nice little graphics. We can just keep it there. OK. So the live editing of the CSS. So if we can go back to number 2. And those styles here change with this metrics view. So if there was any padding, border, margin, and position, they would be painted in different colors on the when you're hovering. So the hover color does matter. So we'd have orange, yellow, green, and blue. So all of those elements would have that color. They wouldn't. We choose.
Yeah, I find, or I have found in the past, that margins and borders and padding always is time-consuming to troubleshoot when you have elements that aren't positioned exactly where you want. There might be like a hidden padding being applied to it, and you have no idea where. This is Web Inspector will tell you exactly what values are applied to the given element quickly.
Yes.
And what you're going to show in a moment is you can even tweak those changes from here.
So let's add a top border of, let's see, 2 pixels? No, let's make it 20.
Yeah.
Whoops.
Well, give him some more work to do, Konrad.
Border width top 20 pixels is set on the element style. You can see now does not seem to want to apply for me. Why? Maybe I need to specify an actual border color. Sorry? Border style. Solid, yeah, let's go solid. There we go. Solid. Now it has applied. So if we, you know what, let's just, oh, nice, gave me even, why did it go 3 on the other, on all those sides?
Interesting. Why indeed?
Margin 15. Let's go. Padding 5. Okay, so can we go back to number 3? So you can see this is the moon, has all its nice little styles applied. So this is hovering over the element itself. Now if we hover over just the metrics, we'll see this is what the margin is. We have our border, we have our padding, and then we have the actual element size itself. So like Adam said, when you're dealing with padding, border, margin, all that stuff, these will save time.
Lots of time.
Back to 2.
And it was real time, right? No, no Control F5, no more refreshes and reloads. It's just it just happens.
Oh, and disabling all these styles that we added is just a click of a button. Just get rid of the checkbox, and they all disappear. And if we can just have 3 again for a minute, just show them being added and disabled one by one. And they all go away.
Does this get saved anywhere?
Yes, this question is if does it get saved. That feature I know does exist in Upstream WebKit. I'm not sure if our port has it just yet. There may be a way to save it under resources. I'm just trying to remember if we currently support that or not.
Maybe one of the experiments?
I don't remember. I know that the feature exists. I'm not sure if this specific version that we have on the Dev Alpha Bs does have that. But it's something that we plan to add. Oh, yes. The network panel. This is where things, you can see all the different network timings for the, is this our, yeah, for the game pause. So we have all the network requests that come across for loading all your resources, they'll be captured here. This is not enough to get you an accurate picture. So we can clear the browser cache, confirm, yes. And right now, I'm just going to do Command R. And you don't see it, but the whole page was just reloaded. And so we have all of our HTML requests coming in. Whoop. And something just froze on the tool.
Web Inspector, hold up.
I'm not sure. Let's take, sorry? Oh yeah, I'm going to blame Chrome. Oh, there you go. You see, it is Chrome. That's bad. Okay. But we can go right back.
Do it again.
Yes, we can. And this is where it's going to get really fun. This is Web Inspector, debugging Web Inspector.
Yeah.
Oh. So let's make it easier and just pop it out into its own window. So this is the developer tools. And now here, what we're going to do is we're going to reload Web Inspector. Oops. Some breakpoints already set when I was debugging it earlier. Here, let's disable those and continue. So this was just refreshing Web Inspector in the background. So these are all the Web Inspector resources that came across. Here's the fun one right here. So this is the example we use. We have the HTTP headers for the request and response. We have a preview. This is the same as you would see in your resources view, again with the response. There don't seem to be any cookies that come across. So there's no cookies to examine.
But if there were,
you would be able to see them. And here's also the fun part. This is, you can see it better here. You can, specific resources, you can just filter by them. Just going to go back to that. No. So we can filter by specific resources, just documents. We have style sheets, images, large JavaScript. And the one that we're interested in is WebSockets. So this is a WebSocket request, and this is the WebSocket traffic. All of the WebSocket frames that are being sent to and from Web Inspector between the device and the remote Web Inspector that we have, which is this guy right here. So
this is how Web Inspector does everything in real time,
yes,
because it's done so over sockets.
So the WebSockets are really lightning fast, really quick. So it gives you all of this useful information of all the different messages being sent back and forth. Really large messages sometimes. Really large. Request and response. So let's try and do this again and reload this page. So we have all just scripts, everything, documents. So this gives you a real-time view of how long it took to load the resource for, total milliseconds over network traffic. This is all being loaded from the device, so there's no network traffic, but this is how long it took to process and load the resource itself. There's a couple of points of note, which is right here. We have the initiator column. So this is where this piece of file was requested from. So in line 8 on index.html is where the style sheet came from for the CSS. We have, sorry, let's get back here. So the sources are from line 9, and then your images saying line 1. Here you go, board.js, line 170, and so on and so on. So here, there we have the cookies. There aren't any, but the view is still available.
You showed the headers, right?
Oh, yes. And then there's the HTTP request headers.
Super cool if you're especially in enterprises where there might be, certain
custom XHR, custom headers, and so on.
Yeah,
they're all visible right here.
Security permissions. Maybe you've seen broken images for some reasons, and the root cause is a 403. You'd find that information through this panel. That was very intelligent.
Yeah. So there's the on top of the actual. So you have you get the details of the request when you select it. But if you have a general overview, so you can see it's all HTTP 200s, and gives you, if you can sort by type, you can sort by all these different things, the file size, and all these different ways to examine your timeline.
There's two other important pieces of information on this page. Do you see the two vertical bars here? Each of these represent certain page events.
Yeah. So this is when the DOM content fired. And that's the blue one, and the red one is the load event. So your onload handlers would fire on that red line. There's another. So they're visible also on the network side, but also if we start to record a timeline and we do a reload, just like we did before, so we can see all the different network events coming in here, all the different traffic, and then you have our blue and our red lines here as well that are visible in the timeline. So that's very cool and very important as well. So you can see all your network traffic, all your scripting, all your style recalculation, all your painting. It's all visible right here from your timeline. I like to call it the command center, though.
Mm-hmm.
This is a really cool feature we have that we just added, and this is the frames view. So you can see each individual frame as it's coming in and how long it took. So we can select a single frame. Let's see. Or maybe they're too large. If they're too long, it's hard to fit them in because the view does change. There we go. So we have our 3 different frames here. I mean, you can see this long line here, which has 30 frames per second. Well, that indicates to us that the height of the bars indicates how long that frame took to execute. And what it's filled up with shows you what was executing at that time, or what was it that took so long for that frame to happen, for that frame to occur. So in the beginning, there's a lot of network and scripting traffic. There's some painting going on. And then once it calms down, once the initial load has happened, we can see that we have the first frame was at 43 frames per second and took 23 milliseconds. The next frame, took 34 milliseconds and it was 29 frames per second. So it gives you all that detailed information right here from this view. And you can drill down and see there was a timer fired. That was basically the longest part of the event. And the space that's not filled in is an unknown to us. We're not measuring that. We just know that the frame wasn't called until that time. So we're not sure exactly why the actual frame took that long internally. Well, we know because we've set an artificial time of 15 frames per second, so that's why most of these are so high. But
ideally, developers should strive to do what, between 30 and 60 FPS?
Yeah, you should. Well, ideally, you should strive for 60 frames per second. That's the fluidity level that we're aiming for, and that we want to encourage you all to get.
Mm-hmm.
If you can't get 30, or sorry, if you can't get 60, try and get as close as possible. But if we do get, so this will show what the 30 and the 60 mark is, because there's these frames are so long, the 60 line is just ignored. It's not even displayed at this point. And that's because you don't care, because you're not even close to reaching it. So yeah, so we can examine the different frames. So you can go through, select a few, and it'll, you can examine piece by piece. If you select too many at a time, it'll just go back to the normal timeline view, so it won't, when you hover here, it won't indicate what the frame values are, and they won't be separated by frame necessarily. The other fun part is we have our memory. So here we have our how much memory we're using. Let's see if it actually has any more information when you hover. Usually I discover some cool things when you just leave the mouse alone for a second, but not today. So we have here showing that we have one document, 312 nodes, and there's 37 event listeners that are registered. And as you move along in the timeline, you can see, okay, so there's one less node. Somewhere it got deleted for some reason. If we can expand this to make it nice and long, so you can see how it changes over time. There's one document, and there were two, and back to one. So that's the time here. Mm-hmm. Is when there's another document was added. There's a whole bunch of stuff going on with event listeners and node manipulation. So you can track as these things are changing as part of your timeline. You can see, what's going on.
And it makes sense to see the event listener bar increase as more and more elements are being added to the page over this timeline, right? Like we see at the top, there's the content loaded event, and that red bar there is the page loaded event. And it's at that point I'd expect all the event listers to have been established.
Yes.
Can you clear that, capture the game, like for 2 seconds, and then show us what happened there at 49?
Sure. So let's just do one thing quickly, save this timeline data for later. And clear the capture. Oh, no, wait, clear. So let's get into it.
I can play if you want.
Yeah, Adam, have fun. So I think that's enough.
Right.
Okay. So let's take a look at our events. It's really small. Let's get them all into view. So we have a lot of scripting traffic going on. You can see our events. Ooh, there we go. What's this long frame here? So this was 4 frames per second. Nice. And we can see what the long pull was. It was a draw. Let's see if there's anything specific going on here. We have the call stack visible. And, let's see. Oh, that was set timeout, but this guy right here. So yeah.
This is why the performance is so slow. So we've commented out the right way of doing it, which is following the best practices, and forced it to do a JavaScript timeout of 15 seconds. So
15 milliseconds, or 1,000 over 15.
That's what, yeah, sorry. That's what I meant to say. One thing that we can do is load up the good copy of BrickBreaker,
Yep.
rerun it, and compare it. You want to do that?
Sure. So hold on, let me just save this timeline data again. We have another download.
Ready?
Yep, go for it. So wait for the game to load. And this time it's on port 1338. So 69, go to port 1338, and we're in BrickBreaker. Let's go back to our timeline. Oh, it gives you a pop-up on the when you have to enable WebWorks to be in debug mode, and there will be a pop-up, a JavaScript pop-up that will show up on screen, which will give you the IP address and the port to which, what to connect to. We start on port 1337, and we just keep incrementing for every other application that uses Web Inspector.
So recommendation, never ever enable debug mode in your production version of your app, right? You never want your users to see that or have access to the code.
Unless you're open source, and then it should be fine.
Yeah, sure.
Usually Apple will reject your app if you leave it on. That's not rejected.
Oh, good. That's refreshing to hear. That's good. All right, so we're rerunning the same simulation
Yes.
on the GitHub version of this code, not the modified one.
Right.
Ready? Ready when you are?
Okay, go.
Yep.
Let's see. All right, that's a good time. So we can see the frames. So you see the 30 and the 60 frames per second indicator. So we have a lot of good frames. Again, we have some outliers. So we can see what's going on here. The long pull, again, probably would be draw.js. Is it a similar call stack? Yeah, it's a request animation, and it keeps going that way. There's not too much information that's immediately apparent, but there's some paint calls the frame after. There's a hard one to try and drill down and.
But we are seeing a significant increase in performance.
Yeah, so the simple fact that we had, let's go here, draw.js, so that we're using request animation frame instead of our sloppy little set timeout does make a big difference. Plus, we were using a lot longer or a lot longer period of time instead of, we were aiming for 15 instead of 60 frames per second. So we save the timeline, 2 of them actually. So we have this one to compare to. Let's just save this one again. And we want to load timeline data. So we have our downloads. Download 2, I think, was the one which had all that nice little info, which was really slow. And so we have that back here. So you can save the timeline data and compare it to another one. So you can capture, see what you did, see what it was. You have all the information, all the data is there. And if you want to take a look at what it looks like, it's just this, JSON interpretation of everything that's going on. Has start, end times, line, column number, everything, all the data that was there for your previous timeline capture is here again.
Just did a time check. We got about 5 minutes left.
Okay.
So if we're going to just jump to.
Yeah.
Okay.
So we have the JavaScript console. This is really your friend. You have access to everything from here. This is, as you saw when we were debugging, you can use it to examine the values of variables. The values of the variables are still visible in the actual scope variables as they're indicated. But you can live execute JavaScript while you're paused in the debugger. But you can also do it when you're not paused. So we have access to everything that you have access to window. You have access to window and everything that it's bound to it. So any global variables you can access anytime that you really need to. So it's a really, really cool way to do some testing. If you have an idea of how you want to modify things, it's a really cool, powerful, very powerful tool.
Yeah.
And yeah.
This app uses modules, so you can actually type in one of the module names to see it. So type, is it people maybe, or window.people? You have a capital case P.
Capital?
It's a class.
No, let's see if it's bound to window dot people. No.
Page. Power up is another one. That's something.
Power up. Okay, so that's that module. Yeah.
So real-time access to JavaScript objects, properties, methods.
Yes. So let's see, missile. Another object. What's on there? And instead of opening and collapsing this, we can just go click on the dot, and then we have all of the actual nice autocomplete functionality that's built right in. It's really nice and useful to have. Now, if you want to, let's say we're in here, and we have the div container. So that's container. So we have document dot get element by ID. We have container. So that's that div. And when you hover over this div that's shown in the console, it actually is the same as if you were to hover over it in the elements panel. You can expand, so anything you hover over that's expanded within it, it would be the same deal. Now, so we have container. Let's see if we want to get splash screen. Well, I just selected it, but we want to go $0, and that'll give you the splash screen. So you don't have, you see, if you select it in the elements panel, $0 is just a constantly changing variable. When whatever is selected, you'll be given that element. So you don't have to go through the trouble of typing document.get element by ID. Lots of fun.
Mm-hmm.
Okay, profiles. Okay, this also disabled by default, but what you can do is you can get a JavaScript profile. So I'm just gonna play the game for a minute, run a quick profile, stop. So here you can see what the timing was, where your program or function or game spent its time. You can do it by percentage, the number of calls. So what was called a lot? This went on as function in physics.js. It's right here. So, but did it take up a lot of time? Maybe just a little bit, not all that much. So again, really powerful, really cool. And I think we're all out of time, aren't we?
Mm-hmm.
Okay.
One other cool thing is you can manually run profiles, but you can also inject profiles into the code itself. So if you wanted to isolate a function that you think might be overperforming, you can run this statement to set your starting point in your code, and then you go console.profile.end.
Profile end, yeah. I think it also takes the.
No, I think it's.
No?
Now.
Anyway,
there it
so
is.
there you go. You have test, and all it was doing some draw image calls.
Yeah.
So here you have. More bugs to fix later. Okay. Back to 1, please. And yeah, so there's more information about Web Inspector for us coming up. We have a lab this afternoon it goes into this, a little bit more hands-on and a lot more detail.
Yeah, it's a lot of the similar content, but with tasks. So we're going to give attendees, a sample app to dig through on their own and explore some of these features and play with it at their own pace and speed. But then there's also some other great content. If you've already seen these, that's great. If you haven't, check them out after the show, because we're going to publish all these sessions, of course. And there may be sample apps and code and stuff that you can play with for that too. Cool. But otherwise, do appreciate your time. Thank you very much for joining us today. I hope it's been a good day. And we'll be around and available. If you have other further follow-up questions, by all means.
Yep. Thanks, guys.
Bye.